That light isn't a star at all. It's the interstellar visitor known as 3I Atlas.
And strangely, its light burns blue, hotter than the surface of our own sun.
In astronomy, blue means extreme temperature, far beyond what comets naturally produce. But Atlas refuses to behave like a normal comet approaching a star.
Most comets redden near the sun because dust scatters shorter wavelengths of light.
Yet Atlas grows bluer, as if heated from within by something unexpected.
Scientists watching it describe a color shift unlike anything recorded before.
Imagine a fire turning from green to deep blue without cooling, only heating dramatically.
Atlas once glowed green, a soft bioluminescent hue commonly seen in comet gases.
But now its color is a sharp thermal blue, the signature of extreme heat.
That transition breaks every predictive model we use to understand comet behavior.
When Atlas swung closest to the Sun, another oddity surfaced near the solar corona.
Instruments detected unusual plasma disturbances at the exact moment of its passage.
No one can claim they're linked, but the timing makes scientists pause.
In science, coincidences sometimes open doors we didn't know existed.
So why does Atlas shine blue, hotter than it should logically be?
Natural heating cannot push an object this cool to star-like temperatures.
Something must be adding energy or storing it far beyond standard physics.
Imagine holding an ice cube near a campfire and watching it glow blue instead of melting. That's the scale of contradiction Atlas is presenting to our models.
Its behavior pushes against our assumptions about heat, light, and cosmic materials.
And then there's the question of its internal energy, if it truly has any.
Heat doesn't appear spontaneously at this scale without a driving mechanism.
Could Atlas be undergoing a reaction we've never seen in natural space objects?
Or is it storing ancient heat from formation, somehow released all at once?
But the deeper puzzle is the plasma disturbance near the sun's corona. The sun's outer atmosphere fluttered in ways that caught every researcher's eye.
It's rare for external objects to influence or coincide with solar turbulence.
If the timing wasn't identical, we wouldn't even question a connection.
But the universe loves patterns, even subtle ones hidden in the noise.
The color transition remains the most stunning feature of all.
Green light often comes from simple molecular reactions in comet gases.
Blue light, however, marks much higher temperatures and tighter energy states.
Shifting from green to blue means Atlas is heating dramatically, not cooling. And that is the opposite of what comets normally do near intense sunlight.
Dust should scatter blue light and leave only warm red tones behind.
But Atlas emits blue directly, as if its heat is generated from within. Imagine a lantern glowing brighter, not because of fuel, but because something inside awakens.
That's the sensation Atlas gives astronomers watching its evolution. Its behavior is almost like a story unfolding in real time. Every new observation bends our expectations a little more. Green to blue, calm to heated, Atlas rewrites every rule we apply to comets. The longer we watch it, the more questions outnumber answers. What drives its heat? What feeds its glow?
The disturbance near the corona adds yet another layer to its mystery. Cosmic objects rarely affect the sun's atmosphere indirectly. And although we won't assume causation, the coincidence is impossible to ignore. That's why researchers world-eyed are watching Atlas with growing curiosity.
Its blue signature suggests heat levels unmatched by typical interstellar debris.
If natural, it reveals physics we haven't yet mapped.
If not natural, the implications reach far beyond chemistry or dust.
Imagine discovering a flashlight washed ashore that shines hotter than a star. That's the scale of surprise Atlas presents as it crosses our solar system. And for now, all we can do is observe, measure, and keep asking questions. Because in science, every mystery is an invitation to learn something new.
Imagine a distant blue light pulsing steadily in the night sky.
This isn't a star or a passing satellite.
It's the interstellar visitor we call Atlas.
What makes Atlas unique is its repeating brightness cycle.
Its glow increases and fades with almost perfect timing. Natural comets rarely produce such consistent rhythms.
Most brightness changes are chaotic, driven by random outgassing.
Atlas behaves as if following an internal schedule.
Imagine a lighthouse in space, blinking with deliberate precision.
This repeating cycle hints that something steady powers it.
And that raises a profound question about its energy source.
Atlas shines hotter than sunlight can reasonably explain.
Objects heated only by the sun cannot exceed certain limits. Yet Atlas emits more heat than it receives.
So where is this extra energy coming from?
In physics, excess energy demands an explanation. Either we are witnessing new natural processes, or Atlas contains something operating internally.
Picture holding ice near a fire, then watching it glow hotter than the flame. That is the level of contradiction Atlas presents.
Scientists monitor its brightness cycle with growing fascination.
The cycle repeats like a beat only Atlas can hear. And its timing is too consistent to ignore.
Patterns like this rarely appear by accident.
But the mystery deepens when we trace Atlas's incoming path. The object enters from a region famous in SETI history.
It arrives from the same direction as the WOW signal.
WOW was a remarkable radio burst detected in 1977. It lasted only moments, but left scientists stunned.
For decades, its origin have remained unexplained. Now Atlas approaches us from that same celestial region. The timing may be coincidence, but it's a striking one.
Science teaches us to examine coincidences carefully.
Sometimes they reveal stories we didn't expect. So we ask, why does Atlas pulse?
And why does it glow hotter than the sun illuminates it?
These questions are shaping our understanding of this visitor.
Atlas behaves more like a system than an inert rock. Its brightness, rhythm, feels almost intentional.
Yet nothing confirms that interpretation, only curiosity.
Could Atlas be venting gas on a cycle we've never documented?
Or is something inside regulating its radiance?
Natural or not, Atlas challenges our assumptions.
Most comets flicker with messy, unpredictable bursts.
Atlas, meanwhile, glows like a measured beacon.
Patterns imply structure, and structure implies dynamics.
And heat beyond sunlight implies internal power.
Imagine a device slowly waking, testing its output.
That's how Atlas appears as its cycles intensify. Each new pulse grows slightly stronger than the last.
But speculation is only a starting point in science.
Real answers come from patient observation. And the more we watch, the more Atlas surprises us. Its glow isn't random, and it isn't weakening.
The pulses remain consistent over long time spans.
Something is keeping the cycle steady.
Only two explanations fit the evidence so far.
Either this is new natural physics in action, or something inside Atlas works in an organized way. Nature sometimes surprises us with unknown processes.
But cycles this clean are rare in unstructured matter.
That's why the WOW connection lingers in discussion. Think of it as two clues in a cosmic puzzle. Connections don't guarantee meaning, but they spark inquiry.
And Atlas forces us to ask better questions.
Why does it shine with such disciplined rhythm?
Why does its heat exceed reasonable expectations? And why does its journey begin near the WOW region? 3 mysteries, 1 object, and a sky full of questions.
None of this proves Atlas is artificial.
But none of it rules out extraordinary possibilities. Science advances when curiosity meets good evidence. And Atlas provides both in generous amounts.
Each passing day adds another layer to its story.
Its brightness pulses like a clock counting down.
The universe rarely sends simple messages.
But Atlas might be the closest thing to one.
For now, its rhythm remains a beautifully unsolved riddle.
And the next chapter of its journey is still unfolding.
Imagine standing under a night sky as a pale blue trail stretches across space. That trail isn't a cloud or a jet stream.
It's a massive outflow from the interstellar visitor called Atlas.
The plume stretches nearly 300,000 kilometers.
That's almost the distance from Earth to the Moon. But what makes it stranger is what the plume contains.
Instead of water vapor, Atlas releases mostly carbon dioxide. Natural comets usually breathe water when heated by the sun.
But Atlas seems almost dry, with barely 4% water. Imagine a snowball left too long near a campfire, losing all its ice.
That's what Atlas looks like. Something baked many times before arriving here.
Its dryness challenges our expectations for interstellar objects. How does a traveler from deep space lose almost all its water?
Was it scorched in a previous star system?
Or was it formed from different materials entirely?
The plume size alone is unlike any comet we've seen.
But the mystery deepens when we look at Atlas's motion.
Its orbit remains surprisingly stable, despite the massive plume. Normally, jets of gas push comets off balance.
Outgassing creates tiny thrusts that nudge their paths. But Atlas barely shifts at all. It moves with the steadiness of a guided probe.
I've studied comet orbits for decades, and this is unusual.
Why doesn't a 300,000-kilometer plume disturb its course?
Natural objects rarely show such disciplined stability.
Something about Atlas resists the chaotic forces acting on it.
Could its mass be far greater than we estimated?
A massive object is harder to push off course.
But mass alone may not explain everything we've seen.
Some scientists wonder if the gas escapes evenly in all directions.
Perfectly balanced outgassing would cancel out its own thrust.
But comets almost never release gas that neatly.
So what makes Atlas behave so differently?
Its dryness, its plume, and its orbit raise deeper questions.
Imagine an ancient relic traveling across the galaxy. After eons of heating and cooling, perhaps only CO2 remains. But even that doesn't fully solve the puzzle. The plume is enormous, yet the orbit stays perfectly smooth.
It's like watching a ship plow through waves without drifting.
Natural comets simply don't behave with such precision. Atlas acts almost as if engineered for stability.
But we don't jump to conclusions in science.
We follow the evidence wherever it leads.
And the evidence here is definitely unusual.
Atlas forces us to rethink what interstellar objects can be. Its dry composition hints at a long and violent history.
The plume hints at hidden materials stored deep within.
And the orbit hints at a design too stable for randomness.
Could Atlas be denser than any comet we've documented?
Or shaped in a way that resists uneven forces?
Consider how a perfectly smooth stone skims water better.
Atlas might have similar properties on a cosmic scale.
The low water content challenges what we expect from ancient ice. Even comets from the farthest reaches contain far more water.
So why is Atlas nearly bone dry?
Did something strip its water long before it entered our system?
Or was it built from materials with almost no ice at all? Each possibility opens a different cosmic story. But all stories lead back to the same mystery.
Atlas behaves as if shaped by conditions we don't yet understand.
The plume alone demands an explanation.
Yet the orbit behaves as if unaffected by that plume.
It's a contradiction we cannot ignore. And contradictions are where discovery usually begins.
The more we observe, the more Atlas defies assumptions. Its plume grows, but its path stays clean. Its dryness suggests age, but its behavior suggests precision. The universe rarely offers neat packages like this. Yet here it is, moving calmly through our solar system.
We cannot dismiss what does not fit our models.
And Atlas refuses to fit neatly into anything we know.
Its plume, dryness, and stability form a triad of anomalies.
Together, they tell us this is no ordinary comet.
But extraordinary doesn't mean artificial. Not necessarily.
Nature can produce wonders we haven't catalogued yet.
Still, Atlas prompts questions we cannot ignore.
Why such a massive plume without orbital wobble?
Why almost no water in a supposed interstellar comet?
And why does its stability feel engineered or deliberate?
Whatever the answer, Atlas is rewriting our expectations.
Imagine standing under a dark sky as an unfamiliar blue light pulses above you.
That light belongs to Atlas, an interstellar visitor unlike any we have seen. Atlas doesn't break one rule of nature, but nearly 10 at once.
When combined, these anomalies form something almost statistically impossible.
Imagine flipping a coin 10 times and getting heads every time.
At some point, you stop blaming chance and study the coin.
Atlas forces that same shift in thinking.
Its combined oddities exceed what random cosmic behavior can explain.
One anomaly stands out: its extreme thermal signature. Atlas seems to operate above 5,800 Kelvin. That's comparable to the surface of our sun.
But Atlas isn't a star, and shouldn't reach those temperatures.
Natural heating from sunlight alone cannot cause this. Something inside Atlas appears to generate extra energy.
Imagine a stone warming itself, hotter than the fire beside it.
That is the thermal paradox Atlas presents.
If natural, Atlas may reveal physics we have never documented.
If not natural, it suggests unimaginable engineering.
Either possibility pushes beyond our current understanding.
And that's only part of the mystery. The real shock is how many anomalies Atlas displays together.
Each anomaly alone is manageable. All of them together are not.
Scientists rarely see cosmic puzzles this concentrated.
Nature seldom stacks improbabilities without reason. So we ask, what message is the universe sending here?
Clue 1. The location is tied to the lunar cycle. Clue 2. The subject's resonance frequency is shifting.
And every clue reshapes how we think about interstellar objects.
Then comes the global response, unlike anything before. Humanity is watching Atlas in real time.
Not through faded archives or old data, but direct observation.
Every major observatory has turned its eyes toward Atlas.
Hubble follows its structural details closely.
James Webb studies its chemical fingerprints.
Solar monitors like SOHU and Stereo A track it near the Sun.
It's the most coordinated monitoring of a visitor in history.
Scientists everywhere wait to see what Atlas does next. It feels almost like waiting for a distant traveler to speak.
But instead of words, Atlas speaks through behavior.
Each change in brightness or spectrum carries meaning.
Its thermal signature alone has raised global eyebrows.
We simply don't see cold space rocks generate star-like heat.
Something is happening beneath Atlas's surface.
We don't yet know what that something is.
But it's powerful enough to break our expectations.
Probability tells us this cluster of anomalies is no accident.
Nature rarely rolls perfect dice 10 times in a row.
So is Atlas natural or something more intentional? We cannot assume, but we also cannot dismiss the question.
When randomness fails, patterns begin to speak.
And Atlas is full of patterns we can't explain yet.
Its heat, motion, and color shift defy conventional models.
Each anomaly is strange, but together they are astonishing.
This combination challenges both physics and imagination.
And that's why Earth's entire observational network is focused on it.
We are not watching history. We're watching it unfold live.
For once, humanity is early to the mystery. Not reacting years later, but witnessing in the moment.
Every new frame teaches us something unexpected. Atlas forces us to rethink what interstellar visitors can be. It may be natural, or a sign of physics we've never mapped.
Or, more boldly, it could hint at advanced engineering.
We're not claiming answers, only following evidence.
And the evidence so far refuses to stay ordinary.
Its temperature alone would rewrite several textbooks. Its anomalies combined would rewrite much more.
Atlas is a cosmic invitation to learn something new.
The universe rarely gives us puzzles this concentrated.
And mysteries like this deserve our full attention.
That's why every eye in space is pointed at it.
And why every scientist waits for the next shift in light.
The next fluctuation could reveal something profound. Or it could deepen the mystery entirely. Either way, Atlas keeps the scientific world alert.
Rarely do we get to study anomalies in real time.
Atlas is not part of our past. It's part of our present.
And it may shape our future understanding. Each moment brings us closer to clarity or deeper wonder. But science thrives in that space between certainty and awe. Atlas reminds us that the universe still has surprises. And this surprise might be one of the most important yet.